Okay, so in our first lesson, we learned about these things called special triangles. And in these special triangles, we have some particular angles for which we can get exact values of the side ratios. So like when I do sine of these special angles, I can get the actual exact value of this rather than the value that my calculator calculates. And we know for any scale factor of these triangles, no matter how big or small I make them, the ratios will reduce back to these values. So our special triangles were our 45, 45, 90 triangle, which had side measurements of 1, 1, and the hypotenuse of that one was root 2. And then the other special triangle comes from half of an equilateral triangle. So it ends up being a 30, 60, 90 triangle. And the important thing to remember with this triangle, I guess I don't really need these angle things here. The important thing to remember with this triangle is that across from 30 should always be the side equal to 1. So the smallest side of actually both of these triangles is equal to 1. And then, so see how I have this opposite angle and opposite side pairing? I should always have that. So no matter where 30 is in that triangle, I always want to look across and I'll label that side as a length of 1. Across from 60 in this triangle should be the square root of 3. And the hypotenuse of this triangle is equal to 2. Okay, and that's across from the right angle always. So the length of your sides should match up with how big your angles are. So what I mean by that is the smallest side should always be across from the smallest angle. The largest side will be across from the largest angle, and the middle angle will be across from the side with the middle length. Okay, so that's a really good way that you can remember which of these goes across from which angle. Okay, so that is kind of what we did in a nutshell. And then we talked about how you can, if I have maybe 30 as a reference angle and I want to find the cosine of 30, I will do adjacent to that reference angle, which is this guy, over hypotenuse. And then what I can get out from that is the exact ratio of the cosine of 30 for all triangles, all right triangles that have that angle. Okay, and we know with our modern day calculators, our calculators will give us this value, but we want to kind of know why our calculators are giving us this value. So we're going to try to stay away from using calculators for the next little while. Okay, so in grade 10 we talked a lot about how SOHCAHTOA, like sine, cosine, and tangent, and our ratios of those things were for right angle triangles. And we actually only focused on things up here in this quadrant, and they were between 0 degrees and 90 degrees. So because we can't have angles in a 90-degree triangle that are greater than 90 degrees, we really only focused on the triangles that we can fit up here. So let's say we had a point. Okay? And this is what trig really is. We think about a point that's kind of like rotating on this circle. And then what we do is we say, okay, I've traveled x units to the right to get here, or maybe to the left, depending on where it is. And I've traveled y units up. Okay, and I'm just thinking about this as if it's on a regular plane. You know how we can plot any xy coordinate on a regular plane? Like I can plot the coordinate 2, 3. That means I went over 2 units and up 3 units to get to that point. Okay? And then what we have here is, yes, the hypotenuse of this right angle triangle, but it's also the radius of the circle that would be created by me rotating this point at the same distance away from the origin all the way around. So this is actually what we're doing when we think about trig. We're choosing a point that is technically on some kind of rotation, right? That's how we measure the angle. It's a rotation. And then we figure out how many units up and over or down and over we need to go to get to that point. And then as I rotate this point around, if we imagine this point right here being a fixed length from the origin, it will create a circle, right? Like anytime I draw a circle, I'm saying if this is the center, and I'm a fixed length away from that, or the radius, if I swing that all the way around, I get a circle. That was a really bad circle, but you guys get what I mean. And the angle of rotation that we get is actually the angle in here. And that's kind of like our theta. So we've kind of focused in this upper quadrant right here because we've only ever dealt with angles between 0 and 90. But we can actually go beyond 90. So today I'm just going to kind of introduce you to some foundational level stuff, some terminology that you need to know, and some basics, and then we're going to apply them to some questions after. So if you're wondering, why do I need to know this? We're going to put it all together once we get to the back page. So just some basics for now. Okay? If this doesn't make tons of sense to you, it might make sense after I kind of explain the rest of what's going on. Okay, so the first thing that we need to know is the initial arm. The initial arm is where we start measuring angles from. So it's 0 degrees, right? The start, if I haven't rotated at all, then I must be at 0 degrees. And the 0 degree line that we start at is actually, we can consider it to be like glued to the positive x-axis. Okay, and the reason we need this is because we actually measure angles of rotation from this starting point. Okay, so this right here, that's my initial arm. It's always going to be there. It's always the 0 degree line. So this right here is where we're going to, we can call it initial arm. That's where we're going to start measuring angles from. Okay, the other thing that we need to know is called the terminal arm. And the terminal arm is what is responsible for showing where we've measured that angle to. So let's just say I want to measure an angle of 120. I'm going to start at 0. We rotate counterclockwise, so rotating this way. And I'm going to measure the distance between my initial arm and that angle of rotation. So we'll say that the terminal arm is going to measure some theta. And we measure it from the initial arm counterclockwise. Kylie's. Theta is like, it's just a variable that, and we usually use it to represent like an angle measurement. Okay, so you can say if you want some angle. Okay, so let's just say, as an example, we want to plot 120. Starting from 0, we're going to measure. 120 should be just past 90, so I'm thinking that 120 will be measured about here. So we have 120 degrees being measured from 0. Okay, and this guy is going to be our terminal arm, so you can label that if you'd like. Okay, so far we have the initial arm. The initial arm is just telling us this is where we start. We're starting at 0. And it's considered to be kind of like the positive x-axis. That's where we're going to start. Our terminal arm will rotate from that counterclockwise a certain number, just based on what we have in our question, a certain rotation. And we're always going to be measuring or rotating counterclockwise for positive angles. Can I scroll? Okay. All right, so a couple other little setup things that we need to know in order to do what we want to do on the back of this lesson is we need to know something called the cast rule. So You guys in grade 10 were just focusing on the very first quadrant. This is quadrant number 1 right here. You are focusing between 0 and 90. But there's also quadrants 2, 3, and 4. And we will get different values for our trig ratios as far as like positives and negatives depending on which quadrant we are in. And there's a really easy way that we can remember which trig ratios will be positive in which quadrants, and that is the cast rule. So the cast rule starts in quadrant 4, and I write the word cast, working my way counterclockwise around, and I'll show you what these mean in a second. So we draw the word cast, and this is the quadrant from 0 degrees to 90 degrees. So A stands for the word all. And what this means is that all trig ratios in this section here are positive. So I want you guys to get your calculators in degree mode, and I want somebody to give me a value between 0 and 90.
60.
What was that? 16. Is that what you said? 60. Okay, that works. Okay. I want you guys to take the sine of 60, the cos of 60, and the tan of 60. I'm not interested in the actual values. I'm just interested in whether you get positive answers for them or negative answers. Okay. Essay? In degree mode. Okay, so if I take the sine of 60, the cosine of 60, and the tangent of 60, I get positive values for anything, and you can try another value between 0 and 90 if you want, but you will notice that you get all positive values in that quadrant. Okay, and this is what we're used to. We've been working with between 0 and 90 in grade 10 exclusively. Okay, now if we move over between the quadrant from 90 to 180, I want somebody to pick us a number between 90 and 180. 110. Okay, we're going to take the sine of 110, the cos of 110, and the tan of 110, and I want you to pay special attention to which ones are positive and which ones are negative. And what about sine? Okay. So sine is positive, and cosine and tangent are negative. What do you think the S stands for here? This is the sine quadrant. And what do we notice about sine in the sine quadrant? It's positive, and then cosine and tangent are negative. Okay. So we can probably guess what's going to happen in the quadrant from 180 to 270. What does T stand for? Okay. So if T stands for tangent, which trig ratios will be positive here and which ones will be negative? Tan is going to be positive in its own quadrant, and then sine and cosine should be negative in this quadrant. You can do a test value if you're not sure. Choose something between 180 and 270 and plug it into your calculator. Okay, and then of course the C stands for cosine. And that means that cosine is going to be positive in this quadrant, and sine and tangent will be negative. Okay, and this is the quadrant from 270 to 360. Okay, so if I remember cast, I should be able to tell if I said, okay, 290. I should know that if I entered 290 because it's in the cosine quadrant, if I take the sine of 290, I'll get a negative. If I take the cosine of 290, I'll get positive. And if I take the tan of 290, I'll get negative because it's in cosine quadrant. Nicole?
Some numbers are in two quadrants, right?
Right. So these guys on these lines, we're going to talk about these a little later. But we're just talking about values in between those quadrants for now. Cool? So far, so good? Okay, the last thing that we need to know before we apply some of this to an actual question is called a reference angle. So sometimes I call it buddy angle. So any angle over 90 needs a buddy. called the reference angle. Sometimes it's also called the related angle, so you can add that as well. Okay, different texts use different things. So if you see reference angle or related angle, that is kind of what we're talking about. So anything over 90, it needs a reference. And it helps us determine if we can get a reference that's an exact value, like a 30, 60, or 45. It actually helps us to determine the exact value of an angle over 90. So an angle that doesn't appear as it is in these triangles right here, like if it's not 45, 30, or 60. If it's greater than 90, our reference angle will sometimes help us find the exact value of a bigger angle. And it also helps us with a couple other things. You'll see in some future lessons it will help us find a couple different things. So if I have an example here that says 300. So we're going to try to place 300 approximately where it is. So it's about 30 degrees past 270. So remember, we're measuring from here all the way around to 300. So it's probably going to be somewhere like right here-ish. Okay, the reference angle, or its buddy, is always found between the 0, 360 line and our terminal arm, or the 180 line and our terminal arm, depending on where the terminal arm is closest. So is our terminal arm closer to the 0, 360 line, or is it closer to the 180 line? Marianne? You said it. Yeah, so it's closer to this line than it is to the 180 line. So my reference angle is this angle I just outlined in red. The reference angle is between the terminal arm, and in this case it's between 360. So what is the measurement of the angle that's between 360 and 300? 60, right? This little slice is 60. So my reference angle for this guy is going to be, I can find it by doing 360 minus 300, right? To get that remaining little slice there. Okay, it's not always going to be 360 minus the angle. This one just so happens to be closer to 360, so that's how we calculate it. So really what I'm saying is I'm taking a full rotation, and then I have less 60 than that. So it must be this little slice in here. If I take away that 300 from a full rotation, it must be 60. Okay, so you have to just kind of use your common sense to find out what that little slice is. Okay, I don't need a reference angle for angles that are already between 0 and 90 because they're already acute angles. Okay, so if you have something in this quadrant right here, I don't need to find a reference angle. Okay, it's only for these three quadrants. Good? Okay. All right, so we're just going to practice finding these reference angles quickly. When you see draw the angle in standard position, it's just talking about placing the angle just as we did with 300 here. Just place it rotating from 0 in the quadrants. And you guys are going to draw this a lot in this unit, so we're going to get really used to drawing this like little quadrant grid here, and we'll label the outsides. Okay, and then of course we want to start at 0 and measure 250. So 250 should be just before 270. We're just approximating here. It doesn't have to be perfect, but I know that this angle measurement should be equal to 250. Okay, now I want to find the reference angle or the buddy angle because this is over 90 degrees. But I need to decide, is 250 closer to 180 or is it closer to the 0, 360 line? Alexandra? 180. Okay, so my slice that I need to find is this slice right here. That's going to be my reference angle. Any ideas as to how we might be able to calculate this? Joey? What I just outlined in red right here, this guy right here. How can I find this reference angle in here? 250 minus 180, very nice. Okay, so our reference angle here, I want this entire rotation, but if this part right here, I'll do this in blue, if this is 180, I don't want that part, right? I just want this part in red. So I want to do 250 minus this full rotation up here of 180, and that should give me the remaining little piece. So my reference angle can be calculated by doing 250 minus 180, and what do we get? Great. Nicole?
I'm a bit confused. Which one is like
The terminal arm is what we measured with 250, so it's measuring from 0 to this spot right here.
okay, and the other line is just
The reference angle is the angle that, the acute angle that's related to this angle that's greater than 90. So our reference angle is always between the terminal arm, which is this guy, and the closest either 360 or 180. This one's closer to 180, so it's going to be the slot right between the terminal arm and that 180 line. Okay? So guys, I don't want to ever see anyone using the verticals to find the reference angle. We're always using the horizontal lines to find that reference angle. Okay, let's try one more. We're going to draw our grid again. Okay, we're going to plot 120. So measuring from 0, we already actually plotted this one before. Oh, sorry. 120 is just past 90. Maybe we could say it's like right there-ish. Okay, again, that's my measurement inside here. But my reference angle needs to be between the terminal arm and either 180 or 360. So is this closer to 180 or is it closer to 360? 180. So my reference angle is actually going to be the angle from here to here. Oh. Okay, so how do I calculate this little slice in here, this reference angle slice? Yeah, very good. 180 minus 120. And that should give us a reference angle of 60. Any questions? Yep. Essay just asked, can we always just minus the bigger one from the smaller one? And yeah, I think that's a pretty good rule. So if I'm in the 360 quadrant and I have something like 315, I'll do 360 minus 315. Here, because 250 was bigger than 180, we're going to do 250 minus 180. Keep in mind, though, I'm never using 270 or 90. I'm always using the 180 or the 360 line. Natalie?
What does finding the reference angle like show?
We're going to, you'll see why we need that in our next example. So we'll slide over to that now. Okay. So these are the questions that we needed all of that foundational information for. So I'm going to just kind of list a set of steps. You could write these on the top of your lesson if you want, or wherever you have some space. But I'll show you some steps as we go through this. Okay, the first thing that I want to do is I want to draw my angle in standard position and find its reference angle. Okay, just like we did in our last example. So it just means like measuring from 0 counterclockwise. Okay, so the very first thing that I'm going to do here is I will draw my grid. Again, I said we're going to draw this a lot, and I meant we're going to draw it a lot. Okay, and then I'm going to place 210. It doesn't matter if it's like super accurate, but just place 210 approximately where it should be. So I know for sure it's between 180 and 270, and it's probably a bit closer to 180 than it is 270. So we'll just draw it in right here. Okay, now I want to find its reference angle. So is 210 closer to 180 or 360? Okay, so the reference angle will be this guy right in here. Okay, how can I calculate this? Right, 210 minus 180. So I'm finding this little slice to get my reference angle. And I'll just do it underneath here. And that gives me 30. So I'm actually going to label it in here, 30 degrees. Okay, step 2, we're going to draw our special triangle with the closest x-axis line. Okay, so you guys kind of see that we can create a special triangle now right in here. I'm going to make it a right-angled triangle with my closest x-axis line. So the x-axis will always be a leg of your triangle. And I know that if this is 30 and this is 90, what's this angle down here in this corner? What was that? 60. Okay, and we're going to label our side measurements of our special triangle. So I know in the 30, 60, 90 triangle that across from 30 is always 1, across from 60 is always root 3, and the hypotenuse of this triangle is 2. Okay? We are going to use the cast rule to decide on positive or negative for our specific question. So we always start in the bottom right quadrant and work our way counterclockwise, writing the word cast. So we are in the tan quadrant. I am taking the sign of something in the tan quadrant. What do we know about sign when it's in the tan quadrant? It's negative. So this is actually going to be equal to the negative sign of the reference angle, the negative sign of 30 degrees. Okay, and this comes from the cast rule, the negative part. Okay, now we're going to use our special triangle. So the last thing is decide on the ratio. So if I'm looking for the sine of 30, I'm looking for opposite and hypotenuse in my triangle. So what's my final answer going to be here? Negative 1 over 2. So the negative stays, and then the triangle helps me with my ratio. Okay, no calculators should be used for this at all. We don't need calculators. So in our triangle, 30 is our reference angle because that's the that's like the related angle to 210. So it's always the angle in this corner right here, if you found it correctly using 210. And then I'm doing the sine of this reference angle. So it's opposite over hypotenuse using SOHCAHTOA, right? Okay, we're going to do a couple more of these so we can kind of get the hang of it. There's like a couple steps that we have to do, and we have to get some previous knowledge in there as well with our triangles. Can I scroll to the next? We'll try one more, or a couple more. Okay, 315. So draw your quadrant grid. The very first step is we want to place our angle in its standard position. So place it in the proper position. Marianne? Yep. Okay, see if you guys can place your angle. Let me know when you're ready, okay? Okay, and then the next part of step 1 is to find that reference angle. So see if you can find it once you have your angle placed. Are you good, Marianne? Okay. So 315 should be about here. And then I want to find the reference angle. And this one actually happens to be closer to 360 than 180. So my reference angle, oops, my reference angle will be in this little slice right here. So in order to calculate the reference angle, did somebody do the calculation? Yep. And how did you do that, Isabella? Lovely. 360 minus 315. That gives us our reference angle in there. Okay, we're going to create our special triangle now using the closest x-axis. So I'm always using the x-axis as one of the legs of my triangle. I'm never using the 270 or the 90 line. Okay, and then we're going to fill in the rest of the information. So if this is 45, I know that the other angle must be 45 as well. And then I know that the side lengths are 1, 1, and the hypotenuse is root 2. Yes, you need to memorize the special triangles. Okay, this 45 in particular, we always use the angle that's like the reference angle that we calculated as our angle that we're looking at for this calculation. Okay, cast rule. So we are in the cosine quadrant, but we are taking the tan of something in the cosine quadrant. So what do we know about tan in the cosine quadrant? It's negative. So this is going to end up equaling the negative tan of our reference angle, negative tan of 45. Okay, so I have my 45 in this corner here. I need to know, because we're finding tan, I need the opposite side and I need the adjacent side. So can somebody tell us what our final answer will be for this? Liam? Negative, yep. So it ends up being, in this case, opposite is 1 and adjacent is 1. So we'll just simplify to negative 1. Pardon? Yep. Okay, do you guys want to take a 2-minute break and then we'll finish up the last 2 slides there? Okay, 2 minutes. All right, so so far we've only talked about, if you have phones out still, let's put them away, please. Shouldn't take too long. So far we've talked about rotating counterclockwise. Technically, there's no reason why we can't rotate clockwise, except because we're rotating and kind of labeling our quadrants in this direction, in the counterclockwise direction. If we go clockwise, which would be starting at 0 and going this way, we would actually consider them to be negative angles. And that's just because of the notation. Like, so we've all decided, because we've all decided that we're rotating clockwise and those are positive, if I'm rotating in the opposite direction, it's just to indicate that we're rotating in the opposite direction. So if I did something like negative 45, I would be starting at 0 and I would be rotating 45, but in this direction right here. So this would be like negative 45 degrees. That also makes this negative 90. That makes this negative 180, negative 270, and all the way around this would be negative 360 if we're thinking about rotating in the clockwise direction. Now what I like to do is I usually like to express everything as its positive angle anyways. So if this little slice, this blue slice that I'm showing you here is negative 45 degrees, could I figure out what its positive rotation is this way? What would that green piece be? Alex? How did you figure that out? Right. So I can actually figure out the positive rotation of this if I just take the angle and subtract it from 360. So negative 45 and positive 315 are actually equivalent angles. They're called coterminal angles. So anytime I'm approached with a question that asks about a negative angle, I usually just take a quick step at the beginning and I make it into its positive version. So I can do that really easily by just doing 360 minus the angle, and then I follow the steps as usual. Okay? So we're going to try a couple questions with negative angles. So this one, we actually just figured this out. The very first thing that we can do here is subtract from 360, and we get the positive angle of 315. That's the only difference between these and what we did above. So we're going to follow the steps now to plot this in its approximate location, which we just showed on the previous slide, is about here. And the nice thing about this is I actually already know what this slice is. What's this slice? It's got to be 45, right? Because if I'm rotating clockwise 45 degrees, this little slice must be 45 degrees in there. Okay, so let's make our right angle triangle with the closest x-axis. We'll label the remainder of our sides, 1, 1, and root 2. Don't forget to do your cast rule. We're in the cosine quadrant. So is my answer going to be negative or positive if we're in the cosine quadrant and taking the sine of something in the cos quadrant? What's that, Joey? Negative. So this is going to be equal to negative sine of the reference angle, which we said was 45 degrees. Okay? It's not negative because the angle is negative. It's negative because we're using the cast rule and we're in the cosine quadrant and taking the sine of something in the cosine quadrant. So I'm still deciding on this because of the cast rule, right? Not because the angle was negative. Okay, so can somebody tell me what the negative sine of 45 is? Okay, if this is my reference angle right here, I want, because we're taking sine, I want opposite over hypotenuse. Yep, or in other words, negative 1 over root 2. So your calculator will tell you that this is negative root 2 over 2 because it rationalizes the denominator. It does that process where it will multiply the bottom and the top by root 2, and then you'll end up with negative root 2, and then root 2 times root 2 is root 4, which is just 2. So that's why your calculator spits out for you root 2 over 2. Joey? I would be fine with either of these answers. If you're like finding the exact value of an expression, sometimes it's useful to plug in the version of that with its rationalized denominator. But if you're just doing like a single one like this, I think either of these answers are fine. Okay? Okay, we're going to try two more. So cos of 60, we're going to draw our grid, or negative 60. The very first thing that I would do here is I would just subtract this from 360 and get my positive version of that angle, which is 300. Okay, so now I know a little bit better where to place this angle. So I'm going to approximately place it kind of like down here. Okay, this is the coterminal angle to negative 60. It's just the positive version of that, but they're both in the same location. Okay, we're going to find the reference angle, which is this little slice inside here. Any thoughts on that reference angle? 60, yep. Okay, when the angle is negative and it's already between 0 and 90, or like it's between 0 and negative 90, the positive version of that is just your reference angle. So I already know that this little slice is 60 degrees. Okay, you can calculate it by subtracting from 360 if you want. Okay, we're going to make our right angle triangle. And if this is 60, then this guy up here must be 30, which makes this 1, root 3, and the hypotenuse is 2. Okay, cast rule. We are taking the cosine of something in the cosine quadrant. So as our answer, Yeah, so it's going to be the positive. You don't have to write positive in front, but I'm just showing you just for our purposes right now. It's going to be the positive, because of the cast rule, cosine of the reference angle, which is 60. So if I need the cos of 60, I need adjacent to 60, and I need hypotenuse. So what's our final answer going to be here? 1/2. And it's positive because it's cosine in the cosine quadrant. Okay, why don't you guys try the last one and see what you can do with that. I'll give you a couple minutes and then I'll start writing up my solution there. Okay, the last one is the tan of negative 240. Okay, I'm going to start putting my answer up, but you guys don't have to look just yet if you're not finished. Keep going with what you're working on. Okay, answer is up. So the very first thing that I did here was I switched my angle into its positive version. So I did 360 minus 240, which gave me 120. I saw a lot of you guys placed your angle in the correct quadrant, so good job. 120 and 240, those ones are both not between 0 and 90, so I still need to find a reference angle there, right? So I'm finding the angle between the closest x-axis, which was 180 in this case, and our terminal arm, which is 120. So I had to do 180 minus 120 to get that remaining little slice in between, which gave me 60. So that should always be placed in this interior corner right here. And then I'm labeling the rest of my triangle based on that being 60. And of course, the two legs of my triangle meet up at 90 degrees. So I should have 1 down here. I should have root 3 across from 60. And I should have 2 as the hypotenuse. Essay?
Why is it opposite?
Because we're doing the tan.
Oh, I thought we were doing the sine.
Well, it's in the sine quadrant, so that tells me that tan is negative. So that's what I use the cast rule for. But I'm still taking tan because that's what the question is asking me. So the fact that we're in the sine quadrant just tells us that we have negative for tan. Okay? And then we do opposite over adjacent because we're using the tan of the reference angle, which is 60. So you should end up with negative root 3 here. Was everybody able to get that?
I got it.
Will it have a minus in front of it? Nope, not always. Like the one that we just did up here for cosine. Cosine, we were taking the cosine of something in the cosine quadrant, so it ended up being positive. So it just depends what you're taking in what quadrant. Okay?